Hello, and welcome to a Wittmann B8 Control introductory video. My name is Richard Heckbert, Senior Plastics Engineer and Trainer here at Wittmann. In today's video, we will discuss some of the features, usability, and navigation of the B8 control. The B8 control is the same control for all machine types, whether it be a micropower, ecopower, macropower, or smart power. The control features a 21.5-inch 1080 HD touch-enabled display, and the control follows a long history of similar controls, meaning if you know one control type, learning another is very easy. Some topics in today's video will include machine startup, like powering on the machine, getting the machine ready to run, turning on the drive and barrel heating, logging into the machine, zeroing the different axes, functioning or moving the different machine axes, the different operating modes, Wittmann 4.0 integration, saving and loading a mold recipe, a brief overview of the machine settings such as clamp and ejector movements, injection and recovery settings, quick navigation of the B8 control including the status bar, the operating panel, and the bottom bar, the different help options available to you, and finally, starting a TeamViewer session for remote help. To power on the machine, there is a main disconnect handle located on the back side of the machine. This is a black handle that can be rotated from the horizontal position to the vertical position. In order to be able to rotate the handle, all of the electrical cabinet doors must be shut, and the main incoming power from the wall must be on. If these two conditions are satisfied, you will be able to rotate the handle. Rotating the handle to the vertical position will provide power to the machine. The machine will then automatically start booting the control. The boot up sequence takes about 3 minutes, and the control will give you a step-by-step list of where the machine is in the current boot up sequence. Once the machine is booted, you will be presented to this start page. The first place that I always go to once the machine is booted is the alarm page. This can be accessed by either pressing the alarm banner on the top of the screen or the triangle with the exclamation point in the bottom right-hand corner. On every machine startup, there are some safety checks that have to be required. The safety gates, the e-stop keys, and any doors that allow access to the machine must be checked. This is to verify that the safeties have not been bypassed or that they are functioning properly. This includes the front safety gate, the rear safety gate, the back door, the purge guard, and all e-stop keys. In order to carry out these safety checks, you must either open and close the door or press and release the e-stop keys. The machine will guide you through this process with alarms shown on the alarm page. Once these alarms are cleared and taken care of, you will be able to turn on the drive and start the barrel heats. Turning on the drive and turning on the barrel heats. This can normally be done by using the physical buttons located to the left-hand side of the B8 control. Of course, these buttons are not shown in this video demonstration, but these buttons provide a tactile feedback for when you're moving a machine axis or turning on a function. In this case, we're going to use the virtual touch buttons enabled on all B8 controls. This can be found by going to the virtual touch button page located in the bottom right-hand corner of the screen. The drive on key is indicated by the motor icon. In this case, we have a red ring light indicating that the drive is turned off. In order to turn on the drive, we just need to press and hold until we get a green flashing ring on the drive on key. The green ring light begins flashing, indicating that the motor or drive is turning on. And once the drive is completely on, the light turns to a solid green ring light. In order to turn the drive off, we just press the drive off key. Turning the drive back on, I press and hold the drive on key. The barrel heating works in a very similar way. The barrel heating is indicated by the thermometer icon in the barrel. The red ring light is indicating that the barrel heats are turned off currently. To turn the barrel heats on, I just have to press once the barrel heat on key. The green ring light turns solid, indicating that the barrel heats are turned on. The barrel heating also has another function where we can go to standby mode or decrease temperature. In order to do so, I just have to press once the drive on key while the barrel heats are already on. This changes the ring light to orange or yellow. In order to switch back to our set point, we just have to press the barrel heat on key one more time. To turn the barrel heating off, I just press the barrel off key. To turn the barrel heating back on again, I press the barrel heat on key. The mold heating or hot runner controller, if equipped on the machine, works the exact same way as the barrel heating. There's a red ring light indicating that the mold heating is turned off, a green ring light indicating that they're at the set point, and a yellow ring light indicating that the mold heating has been switched to standby mode. The functioning works the exact same way as the barrel heating. Now let's discuss the 4 operating modes. The 4 operating modes include adjustment mode, manual mode, semi-automatic mode, and full automatic mode. Adjustment mode, or setup mode, as indicated by the L bracket with the dot in the middle, is where the machine moves at a low speed, low pressure. These speeds and pressures can be set on the machine general adjustment page. Additionally, the machine can move beyond the profiled set point, meaning, for example, the mold opening can move beyond the mold open position to the maximum mold opening stroke. Manual mode, or hand mode, as indicated by the hand icon, is where the machine moves at the set profiled speeds and pressures. Additionally, the movements cannot move beyond the profiled positions. Semi-automatic mode, as indicated by the rotating 3 arrows interrupted by a square, is one molding cycle where then the operator must intervene by opening the door, removing the part, closing the door, and pressing cycle start. Full automatic, as indicated by the 4 rotating arrows in a complete circle, is where the machine runs one cycle after another, either with the robot removing the parts or the parts dropping onto a conveyor or into a box. The cycle continues one after another. Now let's talk about functioning the machine or moving an axis. This is normally done using the operating panel found on the left-hand side of the screen, but in this case we're going to use the virtual touch button page. The 4 main axes that come on every machine are the clamp opening and closing, the ejector forward and back, the injection unit forward and back, and the screw forward and back and rotate. Additionally, this machine has an air blow as well as a core puller. Depending on what options or machine movements are enabled on your machine or equipped, there may be more or less functions and movements available to the buttons available to you. In order to move a machine axis, you must be in either setup mode or manual mode. Of course, in setup mode, you're moving at a low speed, low pressure, which is really good for mold setting. In manual mode, you're moving at the set profiled speeds and pressures. Right now we're in manual mode, and if I want to close the mold, when I'm standing in front of the machine, the mold closing movement would be a rightward movement. This means I press the right button. As you can see, the clamping unit has closed. In order to open the mold, I press the left button. Once the mold is opened, I could move the ejectors forward. I could also then bring the ejectors back. I could move the carriage forward or the carriage back. I could begin purging in manual mode with the screw forward button by pressing once. To stop purging, I press screw forward again. In order to rotate and recover my own shot, I can press and hold the screw back button. This rotates the screw. If I switch to adjustment mode, this will not start a purging program when I press screw forward. It'll just move the screw forward. If I press screw back, the screw will not rotate but just move straight back. Additionally, in adjustment mode, I can move the clamping unit and other axes beyond their profiled positions. In this case, I can move the clamping unit further to the maximum mold opening stroke. Just by releasing the button and pressing again while in adjustment mode. As I've stated previously, normally the machine is moved using the physical touch buttons located to the left-hand side of the operating panel. This gives you your tactile feedback to your fingers and provides a much better user experience when moving the machine. More on the operating panel in just a minute. Now we will discuss logging into the machine. And I should note that the machine can be moved at any time even without being logged in. But to make any process changes or any value changes, you must be logged into the control. There's a couple of ways to log into the control. The easiest way and most simple is to use an RFID token. Below the control screen is an RFID reader, as indicated by an RFID icon. In order to log into the machine, it's as simple as walking up to the machine and holding your RFID card or token up against the reader. After a brief moment, the machine will recognize your token, welcome you with your name, and change to your preferred language. If you happen to not have your token, you can log in using a username and password. To do so, you can press the clock in the upper right-hand corner of the screen. Once you press the login button in the upper right-hand corner of the screen, you then press the green log on button. And now we can type in the username and password. If your user is already input into the machine, you can select from the drop-down list. This user and password should be unique to each individual, or at least to each group of people that are working on the machine. I'm now logged into user level 20. There are a few user levels as default that come with the machine. And one thing to note, the lower the number, the more access the user has. The default user level system is level 40, 30, 20, 15, and 10. Level 10 is the service level used by Wittmann technicians. Level 15 is for assigning RFID tokens and getting the machine connected to the internet. Level 20 allows most changes that the customer will require. This includes almost all settings and all process settings. Level 30 is usually used for mold setters and people that don't need quite as much access as level 20. Level 40 is used more so for operators with very limited access. To log out of the machine, you can either log in with someone else, you can go to the clock menu, press log off, or if the machine is equipped, you can wait for the inactivity timer to expire and will automatically log you out after a brief period of inactivity. Also found in the logon menu is the ability to take a screenshot. To take a screenshot, you must put a USB stick in the right-hand side of the control screen and then come to the clock menu. We can then press the camera icon. I can now take a screenshot of the entire screen as either a JPEG, PNG, or bitmap. Also in the clock menu is the ability to change the language. To do so, I press the clock menu, press the world icon, and now I can change the language, to this case Deutsch or German. This takes a few moments as the machine changes all of the wording in the machine to the language that you've selected. And now we'll switch back to English. I go back to the clock menu, the world icon, and choose English. Now let's talk about the layout of the control. As we've already discussed, in the upper right-hand corner of the screen, we have the clock menu. Moving to the left a bit, we have the alarm bar at the top of the screen. The alarm bar tries to present the most severe alarm as well as the number of active alarms found on the alarm page. The alarm bar also indicates the status of the machine using color. Adjustment or manual mode is depicted by a blue color. Semi-automatic or full automatic is indicated by a green color. A cycle interruption or cycle end is indicated by a yellow color. And an immediate cycle stop or machine not running is indicated by a red color. Moving to the left side of the screen, we have the status bar and the operating panel. The status bar is found in the upper portion of the left-hand side of the screen and is 3 pages with 10 tiles each. The status bar is used to get a quick glance of information of current axis positions, production data, and even has the possibility of moving a couple of machine axes using the virtual touch buttons. The operating panel in the lower portion of the left-hand side is 3 pages with 5 tiles each. These tiles correspond to the physical buttons used to move the machine. Both the operating panel and the status bar are freely customizable by you, the end user. This can be done on the Menu Media Center page. More about this in just a moment. The bottom bar navigation is where we can navigate to any settings in the machine and where we set all of the process settings and production data settings. Within the main window of the control screen is where we can see and set all of our process settings for each type of process setting. Let's go through the navigation of the bottom bar. Here we have the machine general settings. These are all of the global settings for the machine, as well as any general settings. Below this, we have the special programs, so any special options or features on the machine are found on this page. The injection carriage page is where we can set our injection unit, forward and backward movement, sprue brake, nozzle contact force. The mold table is where we would set up our rotary unit if we had a rotating clamping unit. The clamping page is where we can set our clamp closing and opening profile, as well as the mold safety and any other special mold clamping force functions. The core puller page is where we can choose our core puller program, as well as our core puller pressures and speeds. The ejector page is where we can set up our ejector forward and backward movement, as well as any air valves equipped on the machine. The robot page is where we can control the robot, as well as check the robot interface and the diagnosis of the robot to see the communication between the robot and the machine. Moving to the middle of the bottom bar, we have the process settings. We've broken the injection phase into the 3 main phases of the screw. We have the metering or recovery page, where we can set the screw rotation, the back pressure, and the decompression. We then have the injection, where we can set the machine to inject based upon speed with a pressure limit. And then we have the holding page, where we've transferred and now we're holding with pressure for a specific amount of time. The barrel heating page is found with a thermometer, as well as any other temperatures relating to the machine. In this case, we have the TCUs, or temperature control units, the dryer, the flow con, or the water control flow regulators for the mold, and now we can move to the far right. Here we have the quality table, where we can monitor the part quality and reject, have good part, bad part separation based upon the reject. We have process monitoring or machine monitoring to monitor the actual machine and making sure that the machine is staying within the same process. Here we have the actual value graphics, where we can monitor the process using a graphical view, injection pressure, volume flow, volume. And finally, we have the data record page. This is where we can load and store our mold recipes. To navigate within the B8 control, we can use the 3 layers. In this case, we have the bottom bar navigation of the tiles. Within each of the tiles, we have tabs. And within each tab, we have windows. At first, this may seem confusing to have 3 layers, but with just a little bit of practice, it really becomes comfortable and you really start to learn where everything is located within the machine. Just remember that there's 3 basic layers. You have the tiles, the tabs within the tiles, and then the windows within the tabs. In order to open each window within the tabs, just use the drop-down caret. Pressing the drop-down caret opens that window. To close the window, press the upward caret. If you would like to open all windows within a tab, press the double caret down. This opens all the windows. You can then scroll the page between all the windows. To close all of the windows, press the double caret up button. We also have the ability to use split screen. To do so, you can use these double boxes, which splits the screen in 2. This is really useful for maybe you want to use your injection, metering, and holding profile while monitoring the actual value graphics. Let's do so now. I open the injection page, I press the double box, and this splits the screen, moving the injection down to the bottom. Let's say I put the metering down there as well, and the holding third. I can then put the actual value graphics in the top of the screen. This way, I could cycle between my injection, metering, and holding pressure while monitoring my injection process on the actual value graphics page at the top. One thing to be aware is that if you accidentally minimize the bottom half of the screen, you may think you went back to full screen, but your injection tab is still missing, as well as your metering and your holding tab. There's no way to open them from here. You must realize that they're minimized in the bottom of the screen, open them from the bottom, and then to go back to full screen mode, you can press the X 3 times to close each of the 3 windows. Also to note, you can only put 3 windows in the bottom of the split screen. Once I close each of the 3, the screen goes back to full screen mode. Now let's discuss editing the status bar and the operating panel. This can be done by going to Menu, Media Center. You have the ability to edit any of the 3 pages, and this is completely up to you to make it comfortable for you, the end user. Let's edit page 3 on the status bar. I move to page 3 by pressing the number 3 in the bottom of the status bar. And now I can choose from any of these windows. For example, we have the axes or the heating, the quality table and production data, any special programs, the status of the mold, menu, functions, or shortcuts, and then machine keys for moving the machine. To delete from the status bar, I can turn on the delete box by highlighting this in red, and then I can delete tiles from the status bar. Now I can add a tile. I choose a tile that I would like, highlight it in green, and then drop it to the status bar. We could then choose maybe something from the quality table, like our filling time, maybe our current operating mode, any special programs like the energy monitor, shortcuts, and finally, we could put some machine keys in the status bar, such as seldom used functions like maybe the core puller. This way we always have access to moving the core puller. Maybe the heating as well. To edit the operating panel, we can use the 3 pages of the operating panel with 5 tiles each. To configure the operating panel, I have to use this bottom window, Configuration Operating Panel Keys. This is where I can choose these tiles and move them into the operating panel. One thing I would like to point out is that if you notice when I change the operating panel, the color is changing. It's going from blue to orange to green. This is just trying to give you a visual representation that the operating panel is changing, and the buttons that you're pressing to the left-hand side of the operating panel may be doing a different function when you change the panel. This is completely customizable by you, the end user. Now let's discuss zeroing the different axes. There's 3 main axes that can be zeroed on the machines. You have your injection carriage, your ejectors, and your clamp. To do so, we can go to the Machine General page, then the Zeroing tab, and here we have the 3 axes to zero: injection unit, ejector, and clamping unit. To do so, you must be in adjustment mode. And now we can drive each axis in the direction that we want to zero it. For the ejectors, we want them to be zeroed in the back position, so we can press and hold the ejector back button, and we will be presented with a red and yellow indicator. This is meaning the machine is looking for the 0 point, it's feeling the resistance, and once it has found the 0 point, it'll change to a black and yellow indicator. While holding the ejector back button, you can then press the zeroing ejector. This takes the 0 point over. It's as simple as that. The injection unit is done the same exact way. We bring the injection unit into the mold, and then we touch off on the mold. We press and hold the injection carriage forward button, and here we get the red and yellow indicator. It is now changed to black and yellow. Now, while holding the button forward on the injection unit, we can press the zeroing injection unit button. This zeroes the injection unit. To do the clamping unit or the mold, this is done the same way. First, I'm going to close in manual mode so that we can bring it in close. Now that I'm close, I can switch back to adjustment mode, go back to the Machine General zeroing page, and now I can bring the mold in. As soon as the machine finds the 0 point, we get the red and yellow indicator, and then we would get the black and yellow indicator. Once the indicator has gone to black and yellow, we can press the zeroing clamping unit, and this will overtake the 0 position. Let's do the nozzle unit one more time. We can bring the carriage in, we get the red and yellow indicator, and then while holding the button once the indicator is changed to black and yellow, I can press the zeroing injection unit button. This zeroes the injection unit. All of the machines zero the ejector and the injection unit the same way as I've shown. Depending on the machine type, the zeroing of the clamping unit may be different. On a hydraulic smart power machine, it is done the way I have shown. On an EcoPower toggle machine, there's an automatic die height found on the clamping page. For a macro power hydraulic machine, there's an automatic die height setting or automatic pressure box positioning found on this page, the Machine General zeroing page. Now let's talk about the Wittmann 4.0 integration. Wittmann 4.0 integration is the integration of the peripheral devices. These are devices such as the temperature control units, the Flowcon, the dryer, the blender, and the Wittmann robot. These can be found on different pages throughout the machine. Anything to do with temperature is found on the thermometer page. If we move to the heating page, we have the TCUs, or the temperature control units. The dryer, we have the dryer, and the Flowcon, we have the Flowcon or the flow control water batteries. If we move to the metering page, we have the Gravimax or the blender. The robot is found on the robot page. The Wittmann 4.0 integration allows for the ease of use and connectivity of these peripheral devices to all be controlled and operated through the B8 control from one central location. For example, on the TCUs, I can monitor the TCUs from here, and not only that, but I can change their values without having to walk up on a mezzanine or move into the material handling room to get to the dryer. I can do all from the B8 control. To do so, I click on the temperature control unit and then change the setting. Let's say we increase this by 10 degrees. Now, all from the B8 control, I've increased the water temperature on the water control unit by 10 degrees. Not only can I control devices from here, but the machine is monitoring the devices. So if the TCU were to have a problem or go out of tolerance for whatever reason, the machine would be alarmed, and depending on the error analysis chosen, the machine could stop production or alarm. Gone are the days of putting in the wrong setting and or having a problem on a peripheral device and running production without knowing for many hours on end. The other feature of Wittmann 4.0 is all of these set points for each device, the TCUs, the blender, they're all saved with the mold recipe. So as soon as you save a mold recipe, the machine gathers all of that data, saves it with the mold recipe, and the next time that mold recipe is recalled, that data is pushed out to the Wittmann peripheral devices. No longer do you have to go around and set up each of the set points for each mold recipe on each of the devices. It's automatically pushed out. Since we're talking about loading and saving mold recipes, let's discuss how do we save and load data records. To do so, we need to go to the data record page. And now that we're on the data record page, we need to choose our data carrier. In this case, we're reading from the internal memory, or the flash card installed inside the machine control. We could also be reading from a USB stick, or even a networked server location. We then must choose our data record type. In this case, product data is our mold recipe. We have other data record types used for saving different data throughout the machine. Status bar, operating panel, these are used to save the custom status bars and operating panels that we've created. We have service data. Service data is used by Wittmann technicians to load different service values and store different service values throughout the machine. The barrel heating controller values, this is the PID loop used to control the barrel heater bands. Product data, as I've said, is our mold recipe. To save a mold recipe, we first must choose the location and the type. We've chosen internal memory and product data. We can now give that data record a name. In this case, I'm going to name it test. I ensure that that name is entered in this data record name field, and now I press save. This takes a moment as it saves all of the mold recipe data as well as all that Wittmann peripheral device information. Once the machine is finished saving, it'll say ready and it won't tell you to wait any longer. To load a data record, you can choose from the list. In this case, we're going to choose test again. And then I ensure that that name is dropped down into the data record name. I can now load the test data record. This now brings in all of the mold recipe information and pushes out all of that Wittmann peripheral device, the Wittmann 4.0 information and set points. Again, once the data record has loaded, we are indicated with a ready status. We can also copy data records to a USB stick or a networked server location. To do so, I select the data record, I press copy data record, and now I choose the data carrier that I would like to send that data record to. I press ready, and the data record is moved to that data carrier. I can also delete a data record. To do so, I select the data record I would like to delete, ensure that that name is dropped down into the data record name, and then I press delete data record. It asks me, are you sure you want to delete the data record? I confirm, and the data record has been deleted. Let's discuss changing the units within the machine. To do so, we must go to the Machine General page, General tab, Units, Text, Input Limit, User Level System, Window. Here I have the system of units. What's really great about our machine is that we have the ability to mix and match different units. We have the general units. These are all of your position, your tonnage, and your pressures. We can choose between metrical and SPI. Temperatures, we can choose between Fahrenheit and Celsius. Injection plunger, here's where we can choose the unit specific to the screw. We can either choose a stroke-dependent measurement with millimeters or inches, or a volumetric where the machine is calculating the volume in front of the screw with cubic centimeters or cubic inches. We can also choose the injection plunger pressure-specific units. We can choose between pressure-specific or plastic pressure, or the pressure hydraulic, and this can both be chosen in PSI or bar. Lastly, we can choose the injection or metering work. This is a torque value. It's used for special functions within the machine, but you can choose between Newton millimeters, Newton meters, foot pounds, or foot pound inches. Let's discuss some settings of the machine. For example, let's adjust the clamp profile. To do so, we're going to move to the clamping page. And here we've broken the clamp movement into the two different directions, closing and opening. With our machine, you always read the graph and the table in the same direction that movement would move in front of you when you're standing at the control. For example, the closing movement, we're moving to the right, so we're going to read the graph and the table from the left moving to the right. You also need to realize where the machine is coming from and where it's going to. In this case, our open position was 150 millimeters, so when the clamp is closing, we're moving from 150 millimeters to 25, our first profile point. We're doing so at 500 millimeters per second. Then we're going to move from 25 millimeters to 0 millimeters, our closing point, at again 500 millimeters per second. Maybe I could increase this, or let's actually decrease. Makes more sense. We're going to come in fast, and then at the last inch, or 25 millimeters, we're going to slow down to 400 millimeters per second. For opening, we start at the 0 position. We're moving to 10 millimeters, or about a half an inch at 200 millimeters per second. And then we're moving to our mold opening position of 150 millimeters at 499 millimeters per second. We can also set our force for each of these profiles. You want the force just large enough that the machine is able to move at the desired speed, but not so large that if something were to happen, stuff would break. So you want to minimize the force as much as possible, but still allowing the machine to move at the maximum speed you desire. Also on the clamping page, we can set up our mold safety. Here we have a mold safety device stroke of 50 millimeters. This is the distance where the machine is monitoring the mold safety. We have two options. We have mold protection monitoring time, where if we were to hit a part or something were to stick, we would wait 1 second and then we would alarm out for mold safety. Mold protection time means we must make it through that 50 millimeters within 1 second. Mold protection strokes. Mold protection strokes is where we can set up the number of retries. A number 0 means the machine will come in, detect a part, and not continue to open or close. 1 means the mold will come in, detect the part, and then reopen. It won't retry again. 2 means that the mold will come in, detect the part, open, and try one more time. You can try up to 9 times by putting a number 10 in this field. Other settings that we can adjust are the ejector strokes. The ejector is again broken up into the ejector forward and the ejector back. In this case, we just have the one profile point. So we're moving from the ejector back position of 0 millimeters to the ejector forward position of 100 millimeters at 250 millimeters per second with 39.5 kilonewtons of force. Let's say we wanted to profile this ejector forward movement. We could type in multiple ejector profile points. In this case on the ejectors, up to 3. Let's try 2. Here, we're going to move from 0 to 20 millimeters at 50 millimeters per second, slow, and then we're going to move from 20 to 100 at a faster speed of 250 millimeters per second. Now let's discuss the molding process. We've broken the molding process into three functions. We have the metering or recovery, the injection, and the holding phase. Let's start with metering. For metering, we're going to start from a 0 position on the screw, and we're going to move to a shot size of 40.54 millimeters. We're going to rotate at 200 millimeters per second, and this is a peripheral velocity, meaning it's the amount of circumferential distance that you're traveling within that amount of time. It's not based upon RPM. RPM is displayed based upon the peripheral velocity. Additionally, on the metering profile, we set up our back pressure. In this case, we're metering with 740 psi back pressure. We then choose a decompression stroke. Here we're moving 1.56 millimeters at 10 millimeters per second. We can choose whether we have no back pressure only in automatic mode, or back pressure in manual and auto mode. Moving to the injection phase, we've now built our shot to be 40.54 millimeters plus 1.56 millimeters. And now we have our injection starting at 45 millimeters, moving hopefully to around 0. Injection is velocity dependent with a pressure limit. In this case, we've profiled using 7 profile points to profile the injection speed from 80 to 154 to 99 to 50. We've also increased the pressure and then decreased the pressure. Hopefully, during injection, we're interrupted by the transfer position or pressure. This is found on the holding page. The holding page, we can choose down here our changeover to holding pressure. The three basic ones are time specific, volume specific, and injection pressure specific. Once we've chosen the type of changeover we would like to use, in this case we're going to use volume specific. We could change this to pressure specific. We can then enter our transfer position in this box here. In this case we're at a 0.5 millimeter. Once we've transferred, we begin the holding phase. The holding phase starts at 0 and then counts up to the holding time. We've also profiled our pressure for the holding phase. We're starting at a higher pressure of 14,000 and moving down to 8,500 for the end of the holding. We can choose if we want holding pressure to be on, if we want no holding pressure, or maybe we want holding pressure but still keep the holding pressure time. This way we don't lose that holding pressure as part of our cooling time. Cooling time is also set on this page. In this case, we have 6 seconds of cooling. Lastly, I would like to point out that on the holding page, we must have a monitor here where we're monitoring the amount of time it takes to get to holding pressure or to reach the transfer point. This way, if something happens during injection and the machine never reaches the transfer point, it's not sitting there all day trying to inject that screw. In this case, we have it set for 5 seconds. The machine must transfer within 5 seconds, otherwise we alarm out for incorrect changeover. I also would like to describe the metering profile is found with the backward arrow on the screw for an icon. The injection is a forward arrow with a V for velocity control. The holding pressure is the forward arrow but pushing up against something with a P for pressure control. Let's discuss the alarm page. To get to the alarm page, like we've talked about already, we can press the alarm banner at the top or the triangle at the bottom. Let's create an alarm. For example, let's change this injection profile to something that doesn't make sense for the machine. We've now caused an alarm stroke overlap injection. It's alarm number 197. Let's say in case you don't know what this alarm is and we need more information about it, all we have to do is click on the alarm itself. This brings us into the alarm chapter directly to the alarm number 197. We can then read some causes of why that alarm happens and how we can acknowledge it and clear the alarm. Different alarms have different ways of clearing. Once we've read about the alarm and know how to clear it, we can close the user manual and then fix whatever's causing that alarm. In this case, it was our strange profile. The alarm is automatically cleared. Also on the alarm page, we have the log. The log keeps track of every alarm that occurs on the machine, as well as every value change, user log in, log out, and data record loading and saving. We can filter this with the log filter. I can filter by just alarms. In this case, I have every alarm. The red is when the alarm occurred, and the gray is when the alarm was cleared. I could also filter by specific alarms, in this case 215 for drive 1 stop. This is every time the drive was turned off and switched on. I can filter by users logging in, logging out. I can filter by value changes. What's really nice is that the old value is stored as well as the new value. Any data record that's loaded and saved can be viewed here. And then miscellaneous is in orange. Other help that is available to you is found throughout every page of the control. If we go to the injection page, maybe we're not sure what this delay injection means. If I click on this delay injection, I get the number input pad, and in the bottom left-hand corner I have the question mark. I press this, it brings me directly to the injection page, directly to the injection chapter. Also on within each page, in the upper left-hand corner, I have the help mark. This will bring me again to the user manual, specifically to the clamping and mold opening and closing chapter. The other help that's available to you is found in the menu, help. And here we have the manual. The entire operating instructions is loaded in. In this case, let's say we want to look at the maintenance chapter. I just select the maintenance chapter and then view it on the display. Now we have chapter 8, the maintenance chapter. We have the user manual for the B8 control. In this case, maybe we would like to learn about the APS. I can click the APS chapter, and chapter 23 is displayed in the display. We also have the wiring diagram, or the electrical schematics. The electrical schematics is displayed here, showing the electrical schematics with pictures. The entire electrical wiring diagram is loaded into the machine. We also have the parts list, as well as the mechanical drawings. In this case, we're showing the Smart Power hydraulic clamping unit with diagrams and part numbers. For further assistance, you can always call our Wittmann main number and speak to one of our service representatives. In order to better assist you, we have the ability for remote service. In order to start a remote service session, you can go to Menu, Internet, Web Service. On the Web Service tab, you can press the Automatic Start button, and this will automatically load the TeamViewer application and present you with an ID and a password. The ID stays the same all the time, but the password changes each time. This way we can only gain access to your machine when you allow. We can change any values within the machine and load and change different programs. The only thing we cannot do is move the machine. The virtual touch button page is completely locked out during a TeamViewer session. That's all for now. I hope you have enjoyed this introductory video to the B8 control. If you have any questions, please reach us at our main number of 860-496-9603. And also check out our YouTube page for more videos as well as other B8 tutorial videos.